systems of equations, and so vocabulary is very important. So you'll see some of these words in this unit. So you're kind of used to some of these already. Identity, independent, you've seen that. Infinite solutions, intersecting lines, no solution, one solution, parallel. So some of these are overlapping from the last unit. Okay, some of them will be new. So the newest term is called the system itself. So when it says systems, that means you're going to have more than one equation at a time. So when we go to first page 1, you're going to see 2 equations that you're going to have to graph on the same coordinate plane. So we call this a system because it's more than just graphing one equation on the coordinate plane. So basically 2 or more equations means you have a system. Okay, we only deal with 2 at a time. Now when you take upper level math, you might end up with a system that you might have 3 equations at one time. Okay, in Algebra 1, we're only going to be doing 2 equations at a time. So our first lesson, like I said, I would not consider this part new, except for you're putting, you know how to graph. You're just putting 2 instead of 1 on a coordinate plane. But when it says solve, solve simply means, and you want to write this down, okay, solve is another, this is, you get solve, part of the root word for solve, the word would be solution. Okay, that comes from that word. So basically it means that you are finding the intersection. Okay, write that down. Because you have to know what solve the system means. It means you're looking for the intersection of the 2 lines. So where are these 2 lines intersecting on this coordinate plane? And then you would just read it and you would write your answer as an ordered pair. So your solution would be the coordinate, okay, where these 2 lines meet. So let's just go ahead and graph these 2. It's a very good visual for you. So I'm going to start with -2. It's also probably a nice time when you could actually use 2 different colors, because you could actually see the 2 different lines and sometimes see where the 2 points overlap one another. Okay, especially if you're a very visual person. So we're going to start at -2, and then since the slope is -6, I'm going to count up 6 and then to the left 1. Okay, now I'm not going to connect it right away. I eventually will connect it, but not right away. I'm going to go ahead and do the second line. Start at +3, and the slope is -1. I'm going to go up 1 and then to the left, so I can already see that those 2 points are intersecting one another. Okay, up 1 to the left, and if I want to, I can go ahead and read that coordinate. -1, 4, I already have my solution. So like I said, this part isn't completely new because you guys already know how to graph linear equations. It's just graphing 2 on the same coordinate plane and simply telling me where the 2 lines intersect one another. Now, sometimes they will already be in slope-intercept form for you, and sometimes they will not. So again, we already know how to solve for y. All right, let's look at question number 2. Okay, now we're going to solve for y because it has to be in slope-intercept form in order to graph it. So I'm just simply going to move this to the other side. Okay, so that's going to be y equals to -2x plus 3. I'm going to do the same thing here, solve it for y, so I'm going to move this over. Now that's going to be -y equals -x plus 3. And then I'm going to divide everything by the negative. So y equals +x minus 3. So don't forget to bring that down right here as a -y. So here are my 2 equations I'm graphing. Okay, simply solving for y. Again, that's not new. So I'm going to start with the y-intercept of positive 3. I'm going to go down 2, over 1, down 2. I could also go up 2, then to the right 1. Okay, I'm not going to connect it just yet until I do the next one. Starting at negative 3. And then my slope is 1, so I'm going to go up 1 over 1. And then I can see that these two overlap right there. Okay. So I'll draw my lines. Okay, and then I will write the solution. So I've just solved this, and I have 2, negative 1. 3. So in question number 3, again, we got to solve for y. So I'm just going to move the 4 to the left. So negative 4 equals negative y. And then I'm going to divide by the negative. So that's going to be 4 equals to positive y. So again, this is a horizontal line. How do I know it's a horizontal line? Because it only has one variable, and that variable is y. Okay. So I'm just going to go ahead and graph this horizontal line. There's really no points to do except for draw a horizontal line. You could always look at it on your calculator as well. So you could always hit your y equals key. Make sure you're graphing it correctly. So for this one, I need to solve this one for y. So I'm going to rewrite it over here. All right, I'm going to move the 2x to the other side. So that's negative y equals negative 6x plus 2, and then divide by the negative. So that's positive 6x minus 2. So here's my second equation that I need to graph. So I'll start at negative 2, and then I'm going to count up 6 and over 1, and I can see it's hitting that horizontal line at 1, 4. There's my solution. And then I can just connect the 2 points. All right, so I'll have you guys do the last one here, and then I'm going to be adding one for you in a second. So I want you to see what's going to happen with number 4. So try it out, see what you get. Hopefully you got this answer right here. You should have 2 parallel lines. So what do you think you would write for that? There's no solution because we just said the solution is where the 2 lines intersect. If lines never intersect, then you do not have a solution. We simply write no solution. Okay. Now there's one other option you can have. I want you to write this down. So let's just say, and just draw this at the bottom of your paper. Here's a coordinate, x and y. Here's the line, okay? Now, you can have what we call infinitely many solutions. That's the opposite of no solution, just like we do when we are solving equations. So that means you're graphing the same line 2 times. Please write this information down, guys. Okay, these little notes that I'm writing, you need to know. Infinite many solutions means you're graphing the same line twice. So that means when I draw this line and I draw the same line again, they're intersecting at every single point. So we simply say infinitely many solutions. So in conclusion, there are 3 types of solutions you can have. One solution where they actually intersect, no solution where the lines are parallel, or infinitely many where you have the same line twice. Those are the 3 available options. Okay. All right, so this half sheet of paper should be picked up at the door. And then what we're going to do, it says, first thing it says, we're going to solve or isolate one of the variables for x or y. And then I gave you a hint how to determine which variable you would like to isolate. You want to look to see if there's a coefficient of 1 in one of the equations. So, because Otherwise, you're going to be dealing with a lot of fractions if you don't. So look for the coefficient of 1. Okay, so I'm going to kind of highlight that. Okay, you're looking for coefficients of 1. And then once we do that, the reason why it's called the substitution method, because we're going to substitute it, that expression into the other equation. Then we're going to solve the equation. Once we get an answer here from step 3, we're going to take that answer and substitute it back into step 1. There's that word substitute again. Okay, and then we'll write our final answer as a relation, as an ordered pair. So we are doing the exact same thing that we just did with graphing, but we're doing it all algebraically. Okay, so without a visual, without graphing the slope and the y-intercept. And so you might say, well, why can't we just always use the graphing method? Why do we have to resort to a substitution method? Knew you were thinking that. So the graphing method is great when they actually intersect at integers, you know, your positive and negative whole numbers. What happens if it's like between the grid and you can't tell if it's a half or a third or a fourth? Substitution method can give you a coordinate if it's 11/7. Okay, you can say 11/7. That's the x coordinate. Y coordinate could be 1/5. You could never do that on a graph. Okay, so substitution method will give you exact answers, whether they're integers or whether they're fractions. Okay, so that is definitely an advantage to the substitution method because you can get exact coordinates. So let's just go back to our problems. Okay, right here. All right. And we're going to take this problem. You're going to be looking at your side notes, the printed notes that I just had on the board, and we're going to follow the steps because you need to know what each one of those steps represent and what I'm asking you to do. So step 1 says to look at your equations, solve one of them for x or y. I did give you a hint. I said look to see if you have a coefficient of what? 1. Here it is right here, 1x. So you're looking for coefficients of 1 because they're easier to solve. Because if I solve for y, then, you know, this will come out okay because I would be dividing by 6, but then that was going to give me a 1/6. So you'll be dealing with a lot of fractions. So that's why I said look for coefficients of 1. So if I'm going to solve this for x, I just need to move the 6y to the other side by subtracting it over. And I've done step 1. Okay, that's step 1. Isolate one of the variables for x or y, and I gave you a hint, look for where the coefficients are 1. Okay, step 2 says to take this, because now, what is another word for equals? Who remembers? What's the word we use for equals in a word problem? Is. Somebody said it, okay? So equals is. Okay, that's what this means. So now I am saying x is negative 6y minus 12. That is what x is now. So where I see x here in the other equation, it is now going to be called 6y minus 12. We're going to substitute it. It's no longer x because I'm saying x is negative 6y. Here's my substitution right here. Minus 12. There's my substitution for x. This is my x. Write down the rest. Plus 8y equals 0. Okay, so take a look. Make sure you understand that step 2. Take the value for x. X is actually an expression. Okay, and put it in for x. And you remember, whenever we substitute, we always use what? Parentheses. Okay. What's the third step on your paper? Solve the equation. I got it all set up. Now I just distribute and solve for y. Okay, so this is going to be negative 24y minus 48 plus the 8y equals to 0. Continue solving for y. Combine your y's together. How many y's do I have? Negative 16. Okay, continue solving, because that's all we're doing now, just solving a basic equation. Negative 16y equals to 48. Just move it to the other side. Divide by negative 16. All we're doing is solving. We're still on step 3. So y equals negative what? 3. Very good. Okay, so that is step 3, is just solving it. What does step 4 tell you to do? Very good. It says take this answer from step 3 and substitute it back into step 1. Remember, this was step 1 right here. So we're going to take this answer, substitute it in for y in step 1, and then we will have our x. So I'm going to say x equals negative 6. There's my y that I just found from step 3. And now negative 6 times a negative 3 is a positive what? 18. And what's 18 minus 12? 6. What's my last step? Write the final answer as a coordinate. So which number comes first? X. And then your y. That's the process. Now, obviously, it took me a little longer because I'm going step by step, making sure you understand when you're reading what you're doing. It will go a lot faster once you learn the steps. Okay? So this would have been the same answer we would get if we were to graph these two equations. They would meet at or intersect at 6, negative 3. Okay, we just did it all by hand instead of graphing it. That's it. Same answer. All right, we're going to come back to number 2 and let's do number 3. Okay, so let's try 3. We'll come back to 2 in a second. All right, step 1 is to isolate one of the variables, and I said look for coefficients of 1. Do you see one? I do. Right here. Okay, that's the coefficient of 1y. So I'm going to solve this second equation for y. So I'm going to move the 2x to the other side. And now y becomes negative 2x minus 3. Okay. Now I like to always circle or box my step 1 because I know I have to eventually come back to it at the end. Okay. Next step, where I see y here and the other equation, I am going to substitute it with negative 2x minus 3. Okay, so I'm going to just bring down the negative 2x, minus sign. I'm going to replace y with this negative 2x minus 3 equals negative 3. Okay, then I'm going to just now solve it. Okay, the third step is the longest, where you actually solve, distribute, and solve. So I'm going to have 2x. A negative times a negative changes that to a what? Positive 2x. And this should be a negative. And then a negative times a negative will be a positive 3 equals to negative 3. So what happens with the 2x's? They cancel each other out. Okay, then I'm just left with this. What does that mean? It means no solution, just like it meant before when we used to solve equations. If you end up with two numbers that do not equal one another, because this is not equal, they do not equal, so that's a false statement. That means it's no solution. So if I were to graph these, that simply means these would have been parallel lines, because parallel lines don't intersect. And those are the ones we saw in the graph a few minutes ago where you have no solution. Go back to number 2. So let's do number 4. So in number 4, okay, we're going to solve this for x because that's the coefficient of 1. So I just need to move the 5y to the other side. Okay, so I end up with X is now negative 5y minus 4. So where I see x in the other equation, I'm going to replace it with negative 5y minus 4. The rest is just solving. So once you have it set up, the rest is just solving this equation. So this will give us 15y plus 12 minus 15y equals 12. What happens again? They cancel out. You're left with a true statement. So what does that mean? Infinitely many solutions. Okay, so that means that these lines were exactly the same. If you were to graph them, you would just end up overlapping the lines when you would graph. Okay. All right, we're going to go back to, like I said, number 2. Number 2, the good thing about number 2, step 1 is already done. How do I know that? You already have one of the variables isolated, y equals negative 3. So you already have the y coordinate. So technically you're only finding x. So this is like half of the steps. Step 1 is done. So I'm going to, where I see y in the second equation, I'm going to replace it with negative 3. There we go. So this one is pretty easy because you already have the y value, so technically you just need to find x. So really this is the same thing as plus 3. So we'll just go ahead and solve it. Negative 2x equals to negative 16. Divide by negative 2. So x equals to 8. You don't have anything else to do because they already told you what y was, except for just write it as a coordinate. Okay, so that's why I kind of saved that one to last, because it didn't follow all 5 steps. Okay, this y coordinate was already given. All right. All right, same thing for number 5, so we don't need to do that. All right, so I'm going to have you guys do number 6 on your own. Okay, and then we're going to move on to doing some word problems. Okay, so I'll give you a chance to try to get number 6. Okay, so for the word problems, notice right now I have up here do not solve. So basically we just want to write what the 2 equations are, because right now there's another method you're going to learn that's going to help you solve these a little bit faster. So we're just going to learn now how to set them up. Once we learn that new method, we'll come back and actually solve them. So today, we're just going to learn how to set them up. So it says the school that John goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 adult tickets and 6 child tickets for a total of $126. Okay, the school took in $336 on the second day by selling 12 adults and 12 children. So what is the price of each? Okay, now I want you to get in the habit of knowing what it means to define the variable. So please write this down, because when we actually have a full day of word problems, the very first thing I'm going to ask you to do is define the variables. And that should have an S on it. And what that means is to write in words what each variable will represent. So I'm going to model what I mean by that. Okay, so please write this down, because someone later is going to ask me, what does it mean to define the variable? And I'm going to ask you to go back to this page where you wrote it down. Okay, so please make sure you have it written down. So if I say define your variables, you're going to say, okay, A is going to represent adult tickets, or whatever variable you choose. Okay, you could say X and Y if you want to stick to that. And C for the child. Okay. If you wanted to use X and Y, then you would just say X and Y. So you get to choose your own variables. So now we're going to go back to the problem. So if it says 3 adult tickets and 6 child, gave them a total on the first day of 126. There's my equation right there. On the second day, the sales total 336. You had 12 adult and 12 children. Okay? And that's all I want you to be able to do right now. We'll solve it later, because I'm going to show you another method which helps you to solve this type of system. Okay, let's go down to number 8. We're going to do the same thing. So now we're talking about adult tickets and student tickets, I believe. It says the school band at Brenda goes to is selling tickets to the annual dance. On the first day ticket sales, the school sold 7 adult tickets, 3 student tickets for $97. Okay, next day they took in $59, selling 5 adults and 1 student ticket. So again, you can define the variable however you like. Okay, I'm going to say A for adult ticket, and S for student. Okay, so on the first day, we have 7A plus 3S equals 97. Okay, that's right here. On the second day, we have a total of 59. We have 5 adult and 1 student. Please don't write that 1. We just say S. Okay, we got to get out of the habit of writing a 1S. Okay, and that's what I want you to be able to do for right now. We'll come back later once we learn the third method that you're going to learn to solve them. Okay. All right, so your homework is on the next page. You have a few graphing ones to do, and you have a few substitution ones to do. Okay, so you're doing and you have the work, so it looks just like your notes that we just finished. Okay, it basically is the same type of setup. Again, do not solve, just simply define your variables and write your 2 equations.